Welcome to Melac Online tutorial. Still on specific heat capacity and heat calculations. Now here is another question. And it reads that a tap supplies water at 30 degrees Celsius, while another supplies water at 86 degrees Celsius. Now, if a man wishes to bathe with water at 45 degrees Celsius, now calculate the ratio of the mass of water, the ratio of the mass of hot water to that of cold water. Now, what are we looking for? The mass of hot water, H, to that of what? Cold water, MC. Alright, please, if you're new to my channel or probably my Facebook, please if you're on Facebook, like my page, share with your friends, and if you're on YouTube, please subscribe to my YouTube channel and ensure you get a notification of all my videos in physics and mathematics. Alright, come, let us get started. Now, in this kind of question here, now it tells you about two things. Now, a tap that supplies water at 30 degrees Celsius and another supplies water at 86 degrees Celsius. Now, this man wishes to bathe with water at 44 degrees Celsius. Now, the question is, how do we marry 86, 30 to 44? Now, here is it. Now, in questions like this, now there is a principle behind it. Now, since it involves hot and cold, now here is it. Now, take note that when hot water is mixed with cold water, now here is what happens. The hot water releases energy, okay? While the cold water receives the energy released from the hot water. Now, in natural sense, you can say that the heat lost by the hot water is gained by the cold water, if that makes sense. Now, let's come back. Now, generally, we know that the general formula when it comes to specific heat capacity is this, that H equals to M, which is the product of the mass, the specific heat capacity of the substance, and change in what? Temperature. Okay? Now let us assume that this is the quantity of heat released by hot water. Okay? So this is hot. Okay? Now, and this is the heat also absorbed by the cold water. And Cc and okay, now this is for the hot and this is for the cold. Okay, now it implies that as a particular amount of heat is released or lost by 86 degrees Celsius of the hot water, now a particular amount also is absorbed. The same quantity of heat that is lost from this hot water is also absorbed by the cold water, and at the end it boils down probably at equilibrium, yeah, because after the release of the energy, this one gains it, then they now settle at what? 44 degrees Celsius. Now, how then do we marry this? Now, it implies that the heat lost by hot water equals to what? The heat gained by the cold water. Alright, so it implies here that the heat loss by hot water is equals to the heat gain by the cold water. Now, if this is now true, and we know that the heat loss gives us this by hot water, and the heat loss the heat absorbed by cold water is this. So we can actually say that MH, CH, then change in temperature for hot water equals to what? MC for cold water, CC for cold water, and change in theta for cold water. Okay, all right, now let us now marry this equation together. Take note, we are told to find the ratio of the mass. Okay, so which means mass and mass is what we're actually looking for, the ratio. And take note that since we are dealing with water, it has the same what specific heat capacity of 4200. In that case, we can actually eliminate it off since they are the same. Okay, so that we won't just bother ourselves. So we were left with what? mH, then change in theta for hot, then equals mc, now change in theta for cold. Alright, now to this end now, for this change in theta for hot, let's come here, then the parentheses. Now for our change in theta, now take note that since this is greater than the final temperature, okay, then we have that 86 minus 44, okay, because since 44 is the final end, okay, all right, and MC at this point we have what? 44, then minus what? 30. So here we have it. All right. Okay, so what we now need to do, since it is the ratio of the hot water to the cold water, which means let's just divide this by MC by MC. Okay, all right, and here we divide this by 86 minus 44. Then here we have what? 86 minus 44. All right, so this will eliminate this, this will eliminate this. Okay, and 44 minus 30, now this should give us you see, 44 minus 30 give us 14, then all over this should give us 42. So here we have that mH all over mc now equals 14 all over what? 42. Now 14 here 1, now 14 here should give us what? 3. So we have that the ratio of the hot water, that means the mass of the hot water to the mass of the cold water will be what? 1:3. Final answer. All right, if you love what I've just done, please share. Thank you and God bless you.